I think one of the great things that Stephen has started to do as part of these field day events is starting to get cross-pollination from other disciplines. So while this has been virtualization field day and most of us are systems and virtualization guys, we have a few delegates here that are storage and backup and networking. And one of the discussions we had over breakfast this morning was the impact of leaf spine or the topic of data center fabric on these systems. So I wanted to pick up that conversation again, and I think we started out with Tim. Tim, so ask the question you asked this morning at breakfast.
Well, I'm going to get thrown under the bus here by everybody, but that's okay. I am not a networking guy. Not a networking guy. I do a lot of other things. I have virtualization, automation, orchestration. Those are kind of my sweet spots. So I've never really been good in the networking space, area that I want to learn, clearly. So we're sitting around the table. I think I'm eating an omelet, and someone says fabric path, and I'm sitting here eating my omelet going, what the hell's fabric path, right? And so I asked because, frankly, I have just a networking guru sitting right next to me, what the hell is fabric path? To which he responded,
hell if I know.
Hell if I know. But realistically, he said, well, that's kind of complicated. We have to talk about different sorts of architectures first for the network, right? So tell me a little bit about the different sort of networking architectures from just a really high level. Where were we?
That's a really long discussion.
Yeah, that's fair, but where were we? Where are we? Why is the network changed to enable fabric path, and what does that thing actually do?
Well, so we have to back up, I guess, for a minute on that because
back up. What? Oh.
No, networking.
Mr. Backup. Mr. Backup.
For the next 5 minutes.
Meanwhile,
talk about networking. It's just a place where I send backups.
Us storage guys are sitting here saying, "Did someone say fabric?"
Yeah. So no, I mean it's the thing that we've done forever, right? Before any of this, talk of fabric, right? Is we had kind of the three-tiered architecture fairly typically, right? You had access switches, you had distribution, you had core. All the traffic went north-south, meaning it came from servers and clients, and it went out of the building, right? Went somewhere. And then as virtualization took off, obviously what started happening is we started getting a lot more density on the network, and we started seeing a ton of traffic going what we call east-west, so between different VMs, right? That's where all the traffic went. We still have the north-south traffic, of course, but east-west was vastly outpacing it. And so a lot of vendors, started coming up with solutions to the problem. Fabric Path was one of the early ones with Cisco, and actually it's interesting because we had this discussion at a previous network field day because at the time something called Trill had just sort of gained some favor, started making some noise or whatever, and it was a protocol written by Radia Perlman who wrote Spanning Tree. And Cisco had adopted it and sort of put some special sauce on the top of it and called it Fabric Path. Meanwhile, we had Avaya who had embraced a competing standard called SPB, or shortest path bridging, which is another solution to the problem. And so those two things were kind of out there. But essentially what Fabric Path does in a nutshell is it solves the problem of spanning tree blocking half your links. And so if you don't know how that works, essentially when you have redundant links between access switches, distribution switches, core switches, every other link, every redundant link is essentially off, can't be used. And that's to prevent loops through the network, right? And that's what Spanning Tree does. It's a very old solution and very inefficient now, and we want all those extra links. We're dealing with 10 gig links, 40 gig, 100 gig. You don't want one of those not working.
Because money.
Yeah, because money, because speed, because, and especially when new speeds like that come out, right, the optics are god-awfully expensive.
But primarily because nerd. So in the storage space, we're always talking about active, and whether you're really using what you've got. I mean, it really is one of those things that just offends us to have something that's not being used, something that's...
As a just in case something goes wrong.
Yeah. Well,
a backup.
It's a waste, just like backup.
So, it's complete redundancy, but instead of, but you're dealing with active-passive, right, as opposed to active-active, right? And you want active-active in most cases.
Absolutely, and if you think about having active-passive as well, there's a time for that reconvergence to actually happen, which is essentially downtime.
Sure.
Which is a key point. And it's then, okay, well, how do I test my active passive as well? Apart from yanking cables or shutting down ports, for example.
Well, spanning tree is kind of a notorious pain in the butt, right? Really. It really is colossally challenging to deal with. Not from its particularly hard point of view, but it does have a lot of idiosyncrasies that really just mess things up, right? So what Fabric Path, aimed in the underlying protocol, whatever, aimed to do, as well as SPB, is say, okay, let's find a way to be able to utilize the every connection we have, right? And so in order to solve the layer 2 problem, they had to go to layer 3 or IP, right? Instead of, frames at layer 2. And so what they said was, well, how about, and I'm summarizing quite a bit here, right? Is let's take the layer 2 traffic that we need to be able to move around the network, and let's run it across the network using a layer 3 protocol.
And so spine leaf then born because that extra load, all of that extra processing power for that layer 3 stuff that was normally done in like the core switching area of our network, right, would have to be moved somewhere else so that we could kind of decentralize it. Is that why that happened? What happened?
Well, so what actually happened? Okay, so you get DFA, it does some stuff, magic sauce, everybody's happy. We rejoiced, ate Robin's minstrels, right? And that was, we were all happy with that. After that, but that didn't suggest a particular architecture, right? Fabric Path can work in any, you still, actually traditionally still had the giant switches and all that kind of stuff going this way. And this is what I didn't bring up at breakfast, is after Fabric Path, then you went to something called DFA, or Dynamic Fabric Automation, which was a further sort of piling on top of Fabric Path. It was a different method of routing. Instead of ISIS, now you're using multi-protocol BGP for the routing over ISIS. So now it's layer 2, ISIS, multi-protocol BGP, so it starts getting more complicated. And right about that point is where you start to see the architecture change a little bit, and it started going wider, right? And so you started seeing the giant switches here start going down to more of the spine switches could be a little bit smaller, and you start to see the width of the leafs go outward. And the other big key thing, and then I'll turn it over to somebody else. The other key thing is, with Fabric Path, you still had the layer 3 demarc. So, your IP address that, your server first sees, right? The, upstream gateway, if you will, the gateway IP address, was still sitting up at the core switch typically, or distribution or something like that, one of the bigger switches. And you're still running something like HSRP or VRRP or some sort of a redundant protocol right there. With DFA, you started moving everything down to the leafs. You start moving your layer 3 demarc down into the leaf area, which then took the load off here and
what's the end
and stuff.
And stuff.
So I think this pivoted into a really great part of the conversation, which I want to be able to pull the storage and the system guys back into the conversation. When we look at ACI, VMware, and then even some of the SDN players like Nuage, we get to talking about overlays and the ability to leverage this innovation in the data center with the leaf spine architecture that have this flat network or fabric that we hear about all the time. And when we want to run NSX on top of a fabric, now we understand what a fabric is. And then the conversation went into silos and how VMware admins want to build their NSX silos that run on top of these data center fabrics, and kind of the administrative challenges that solves. So let's talk about a little bit about the drivers around why we choose a product like NSX and the challenges it creates for the networking folks. So let's pick on, I like to pick on storage guys, and Chris is just a pretty bright architect in general. Let's get them involved in the architecture conversation. So Chris, when we're thinking about things such as NSX, virtualized storage, those silos, what are some of the administrative challenges we run when we talk about troubleshooting from one silo to another?
So should we pick storage?
We can pick storage.
Okay. One of the things that I think was interesting from our discussion today was that there was little talk of, or there was a very small number of storage pools that people were talking about and placing storage into one compartment or other. I was somewhat disappointed that there wasn't a lot of talk about quality of service or other features that would actually make storage more dynamic. So I think one of the things that I think you see is you see a lot of siloing because you've got a lot of static configurations for things, and that's quite a big problem.
So, one of the advantages of me going to the delegate that doesn't know anything about storage, going to 2 or 3 storage field days, is I get to learn the depth of what storage services are. And when, as VMware-centric people, we look at, just virtualize the storage. And when we start to abstract the storage away from the hardware and the traditional storage services, what do we lose? What's some of the visibility? So when you look at a product like vSAN or any abstracted storage service, what are some of the things that, if you're not a deep storage expert, that we lose or sacrifice when we look at a product like vSAN?
I think vSAN's a really interesting one because one of the things that you're doing there is you're replicating that data at a very high level. You're doing it node to node across your environment. So in terms of recovery, if you lose any of those mirrors or copies or replicas, you're rebuilding across those nodes. And as soon as you do that, you're creating back network traffic across the fabric, across the network in terms of the storage. So you're impacting performance, you're impacting the production environment by doing that.
So those are activities that would have happened on the bus of a local, like if I had a VMAX or a large HDS.
Those would have been
that would have been internal traffic that I would have never seen. Now we're taking this bus and we're putting it onto the network. So when I'm talking, when you need to talk to the networking guys, what's some of the things that you're looking for when it comes to redundancy of the bus that now the network has to support?
Excellent
Wheels
question.
on the bus.
Isolation. So you'd want that separate. You'd certainly want it, you'd want that as a separate network. You'd want it protected. I'd be really concerned about things like encryption, where that data is going across the network to make sure it was encrypted point to point. Those are the sort of things that would, concern me.
So is that a network? Is that a service that the network should provide? Because in a traditional,
I'm not a network guy.
Okay.
And I'm not going to know exactly the right questions.
I don't think so. I think I think if the storage folks are going to be throwing data back and forth, I think it's their job to encrypt it.
That's what I see actually just in the people I talk to is the storage folks usually often manage from the SAN switch all the way back, right? I mean, it's the whole. I mean, it's an ecosystem. They're taking care of all that. It's almost not network at all.
So
none of it is encrypted.
So why do I need to encrypt? Yeah. So I've got an isolated network, which is.
But it's not isolated. That's the point. With a hyper-converged or some kind of traffic like that with vSAN, it's on your VM network. You could plug another sniffer device on that same, potentially on the same VLAN, and all the traffic's over there.
I'll take it one step further. You don't have to join a vSAN node to vSAN. You can theoretically just have a vSAN node, and if you know the proper commands for sniffing the network to find out what the little join IP is for vSAN, you can theoretically inject your node into vSAN. Now, sure, your VMware administrator is going to see like this little thing that pops up that says, "Hey,
I'm not sure of that.
There's an unauthenticated node," but the second that happens, with your replication policy, you're getting VMs replicated to that node. So theoretically, bring in like a little Intel.
There's a difference in that. But you can join your host to the vSAN cluster without really being part of the VMware cluster.
Right.
So if you know the GUID ID, then you can join the node. I'm not sure. I don't think you can be part of a replication. Then.
Well, so what you
but
would
you can use the data store.
You could use the data store.
You can mount.
So like local disk.
That's even better than replication.
Really,
you got all of it, not just some of it.
But that's why you need to have that vSAN network separated.
Absolutely, separate and secure.
And what we're coming down to here is the problem that traditionally storage networks, as Curtis pointed out. Dirty secret here, storage people don't encrypt storage networks.
No.
But there is no such thing
because it was physically isolated.
Because it was isolated. Yeah, it was just not practical for someone outside the data center to get on a fiber channel SAN for a long time. And so, the equipment was expensive, it was short range. We just put it in the data center, we plugged a few things into it, and we called it a day.
And you can't do man-in-the-middle attacks.
But now that we're...
anything like that, it's very difficult to sniff that traffic.
But now that we're converging and standardizing on Ethernet, it becomes different. And that's the answer to Craig's question, like, why do we need to do this? We need to do this because we're bringing things together, because suddenly it's eminently feasible to get on the storage network, whether it's, storage over Ethernet directly or vSAN or something like that. And it's eminently feasible to break down these walls and do stuff.
Yeah, so my question on the flip side then, Stephen, is who don't you trust in this chain? And you're saying you don't trust the guy who's a VM admin who has access to that.
No, I don't. I don't trust the guy that hacked the box.
Yeah,
that's the thing.
I don't trust that there isn't a leak somewhere that is a bug in the software.
Yeah, when I talk before we started talking hyperconverged, when I used to talk about storage security, it's like if you have any one of these boxes on this network become compromised, right? The fact that the fiber channel, that the authentication was based on the equivalent of the MAC address. Right, imagine, right, if your authentication was based on your MAC address, which is totally fakeable. That's what we had in Fiber Channel, right? So now you have all that in a box. So any one of the boxes that are part of this cluster, any one of them get compromised, now, you have basically the keys to the kingdom.
So I think that's also, I find that also always difficult with updates, with security updates. Do I patch or do I not? Because quite some patches that are like HTTP or HTTPS attacks, mostly my equipment is not reachable from the outside. So everybody says, well, 80% of your attacks is coming from the inside. Mm-hmm. But isn't there a way, a much more easier route for the one coming from the inside? Would somebody from the inside really need to do MAC address spoofing? Is an Active Directory where everything is connected to not easier to hack?
Actually, here's a bigger thing, right? So when you're talking about security, there's a ton of statistics, and I forget who I was talking to the other night, but it may have been Monday actually, but the average time attackers are in the network now, 243 days without being detected. Right. On the network. Robert Mueller, the FBI, said there are two types of companies, those who've been hacked and those who will be. And I would amend that to say those who've been hacked and those who don't know they've been hacked, right? But if you look at not the script kiddie stuff, not the denial of service attacks, generally speaking, people aren't brute forcing their way through a firewall anymore, right? It's just not the kind of thing that happens. Every one of the healthcare hacks, which came from a state sponsor, but every one of the healthcare hacks that happened over the last year and a half used valid credentials inside the network and were only discovered accidentally when somebody happened to be like, why is the same guy running two different jobs simultaneously,
twice,
right?
Yeah.
I mean, they're incredibly sophisticated attacks. So to your point, right, VLAN hopping attacks or trying to get, all these sorts of things in a lot of cases aren't happening. They're somehow getting an admin password and then just
that doesn't even have to be. That doesn't even have to be a disgruntled employee who's acting as a second agent to steal the corporate secrets. The majority of attacks that we see are, you're spoofing emails, you're phishing attacks where it looks like something valid that the users would use, and they give up their credentials. They click on the thing that gives them their access to the network. And as much as we try and throw things like user account control and all these things to try and lock down the security of the systems, once the user has given over the access to use their credentials on your network, you are as screwed as much as that user has access to stuff. And they need access to the stuff to do their jobs, and that's what you're giving over.
Okay, so let's bring the discussion back to what we started at, which was this movement in the network motivated by the east-west nature of traffic, of VM traffic, has enabled new technologies. So vSAN is taking advantage of a bus that didn't previously exist in the data center, which is exposing new challenges from a silo perspective. Whose responsibility? And our vendor partners, and I'll say that term because we use it at work, our vendor partners are all looking to solve these challenges differently. If we're Cisco, we're saying, you know what, network is the point to centrally manage encryption and security. We'll just, create an encrypted channel for all storage traffic, problem solved at the network. VMware is saying, no, we are the central force of that, give all that control to the VMware administrator. And I'm asking you guys, practically, what are some of the approaches that you've seen or that you recommend for solving the challenge of silos and ownership? So x86 is eating the data center. Ethernet. My token ring, my fiber channel over token ring dream may never happen, but that's okay. But Ethernet is NFV Ethernet is going to be a major driver in the data center. The keys to the x86 is currently held by the x86 administrator, but I need the smarts of the storage guys and the networking guys. How do we pull them into this conversation that has been kicked off by x86?
Well, on the networking part, we are actually giving more and more back to the networking guys. So, and actually taking away more from the storage guys. And that's ideally, we're looking at vVols, which is quite slow in getting adoption by the storage vendors, but vVols would be ideal for us from a VMware's perspective.
I think the reason that's happened, if you look at it traditionally, where has your bottleneck been in your virtual environment? Not typically the network.
No.
It's typically been a storage-related issue.
Yeah.
Which is called my bottleneck in the first place.
So when we say,
all about the storage.
Let's talk about bottleneck. Are we talking about bottleneck when it comes to provisioning? Because I'd argue that the network has been a bottleneck when it comes to provisioning versus storage. Storage guy can tell me, hey, give me 3 terabytes, and once it's provisioned, I can handle that however I want on the VM side.
I think what's happened is that the VM admin has had to learn the storage skill set to troubleshoot performance issues. Yeah. That's what's happened. Yeah. And they've had to get clever, and they've had to learn about queue depths and all these sorts of things.
But Craig, we could say that that VMware badly implemented storage when they first wrote ESX.
Yeah, they took what was available.
Yeah. You could say that, you couldn't reference a large number of LUNs.
Mm-hmm. Do you think that's symptomatic of the industry as a whole, though? Because I know that things like storage and networking are very specific, and there are people that deep dive into those particular areas because they are so detailed. But it's kind of parallel to the conversation we were having about DevOps, where the developers need more access to the systems to get things running, and we're kind of seeing a bit more of a spread and a crossover between our skill sets, if not within individuals, but with two specialists working together.
I think we can all collectively say that we don't trust developers. So the idea of whether you're networking, storage, or compute guy, we all don't trust developers. And storage guys, let's think about this. Our vendor partners,
we trust storage guys.
Oh yeah. Yeah, the storage guys don't trust compute guys, and that's the truth.
We hate DBAs.
Yes, but let's think about this. Our vendor, the major vendors are, with the exception of maybe EMC, has been telling us that storage is much too complicated. Let's simplify it at the x86 thing, and we'll get rid of all of your storage administrators. Now, I'm a reasonable person, and I can't think of the idea that, I can't accept the concept that you're going to get rid of a team of people, and I'll have all the advantages that those people have. What am I sacrificing when I say get rid of the storage guys?
This is something that happens on the network, too, and we talked about a little bit about this morning, right, is everybody in their silo. You need to be there because you're never going to get deep if you're not in that silo, right? Nobody can know everything, and I think all of us, the longer we've been in our careers, realize that we know little. We've kind of narrowed, right? But you'll get the systems guys, the VMware guys, who are like, well, a network's a bottleneck, I'm just going to do networking, right? And VMware helps sort of push that, and they're like, networking, and they just kind of do their own thing and then try and toss it over the fence to the network guys who then throw up their hands. Storage, the same thing, right? People are like, how hard can it be to have a pile of hard drives? I'll just do that. Screw you, storage guys. and the storage guys, of course, know how complicated it is, and then they're saying to the systems guys, quit messing up our crap. So I think there's a lot of finger pointing and a lot of just not understanding that every one of these disciplines is incredibly complicated at the upper levels.
And that's what makes IT infrastructure and IT architecture even more complicated, because with these different silos, there's often a lack of respect of what the other silo does, and that sort of networking must be easier, storage must be easier, so we can do it ourselves. And there's silly examples of a VDI example that going to the storage team and saying, your storage is rubbish, it can't cope with my VDI bootstorm. Right. And the storage guy is turning around going, well, your VMs are incorrectly configured because you shouldn't be having that kind of bootstorm. You've run a virus scan on every single VDI VM at the same time. And so there's this tussle of requirements versus what people want and what people expect. But yet the world is moving forward when silos are being busted, and DevOps, as Sonia mentioned, is a very real thing that infrastructure, I think, is becoming slow to wake up to. And the application developers don't care about infrastructure. They want it to just work, yet infrastructure is complicated. So how do you circle that wheel?
Which is how Amazon has taken off.
Yep.
They just say, point, click, done, got a VM. Don't have to care about storage, don't have to care about network. It just works. It doesn't necessarily work better or worse than what I could get if I put this together. It just works.
And that's where IT infrastructure practitioners need to elevate, first of all, their technical skills, but also their sort of people skills, and really see themselves as providing a service and understanding what developers want, what desktop people want, what, other application vendors want, and move out of their comfort zones and their silos and embrace the networks, embrace the storage, and try and do this. I'm not giving any answers because there aren't any.
I think, Julian, so I think we are rather reactive as an industry, though. So going back to your example, for example, of VDI, oh crap, I didn't realise that my in-get antivirus scan would consume 1,000 IO per VM. Oh, yeah, I agree. I've got a problem now. Now I need to reactively think about fixing it. We don't think about the issues before they happen.
It is, well,
it's difficult to see those ahead of time, aren't they?
Part of that is line of business, though.
Yeah.
Right? I mean, line of business. I'm dealing with a client right now who is completely rebuilding their entire wireless infrastructure, right, across the board, multiple buildings on campus. They're just and it's they've got to have it done quickly, which is a massive project. The reason for that, because one of the lines of business bought a product without consulting IT, because IT is just those weird big bearded guys in the corner, right, that we don't talk to. They bought this product, then came to IT and said, hey, we're going to install this product, and we need your support. And IT goes, well, we don't have the infrastructure. Your product won't work. The thing you just bought won't work. And then the line of business is like, well, this is business. This is mission critical. So go fix it, right? And I think that it's the same inside of IT. Hard to plan, but I think a lot of it is the business leaders not consulting with IT to figure out how difficult or expensive it is.
I think we should go back to one of the things that Curtis just said there, that AWS is the sort of thing that people have done reactively because internal IT is hard and etc. One of the things we've seen this week is actually, at a very superficial level, yes, AWS is pretty easy, as are all the cloud providers, but in actual fact, we're starting to see that there's more and more technology need to be applied to those to monitor and manage them effectively. So we're starting to see the issues of using them coming out, and we're having to go back and fix some of those problems with some of the tools we're seeing.
And
so in
reinvent
fact,
monitoring.
Reinvent monitoring, reinvent deployments, and actually, in fact, as you start using them,
on the other hand,
they become a problem again.
So I'm sorry, guys. This is an extremely impassionate conversation. I thought it would be, because it was at breakfast. But we started out the conversation talking about stuff collectively I think most of the room didn't know about, which is fabric networks. And I think the idea has been that when we look at solutions from our vendor partners, and they come in and they show us the latest whiz-bang software-defined X, we have
bingo.
We need, whenever that bingo word comes up, something should be going off, and we should be talking to our peers across the table, across, in this case, across the table, and talking about, what is it that I'm sacrificing when a vendor comes in and says that they're going to eliminate something that we've been doing 20 years with software, what's missing? And I think we've highlighted some of those things that have been missing, and some of the kind of asking the questions around not knowing what I don't know is by starting off with the question, basically, hey, what is a QDEF whatever? QDEF whatever. That's a storage question, and I don't do storage. But I'm the example. So thanks a lot. I appreciate it.